It's very nice to be back here at JAX. This is a wonderful conference, and I enjoy coming back every several years. I hope you'll continue to have me come back every several years.
Do you actually remember the time when you wrote your first line of code? It's like, you know, this magical time.
So as a new technology comes along, I like to play with it. And so a lot of things I'm talking about today may not be appropriate for your organization now. But I suspect in the next 4 or 5 years, a lot of the things will be pretty standard for you.
Hey, herzlich willkommen. Mann, ist das voll hier. Schön, dass ihr da seid. Herzlich willkommen zur W-JAX 2018. Gerade nachgezählt, vor 17 Jahren haben wir die erste W-JAX hier gemacht. War jemand dabei? Sorry, wenn ich so sentimental bin. Ha, der Arno. Sonst jemand? Nee, ist schon lang her. Okay, wir waren, seit 17 Jahren sind wir immer wieder hier in diesem Gebäude. Damals waren wir noch viel kleiner. Langsam nähern wir uns der Kapazitätsgrenze. Aber es geht noch gut hier. Wir haben genügend Platz. Wir haben insgesamt 9 Tracks parallel, fast zu jedem Zeitpunkt. Das ist eine Riesenmasse an Programm, was wir Ihnen da irgendwie anbieten. Und wie immer war es unser Ziel, Sie möglichst zu verwirren, ja, und Sie möglichst in viele innere Konflikte zu versetzen, weil natürlich bei 9 Tracks parallel fällt es manchmal nicht leicht, sich zu entscheiden, ja, welche Session nehme ich denn jetzt? Ja. Ich hoffe aber trotzdem, wie gesagt, Sie finden einen guten Weg für sich, quer durch dieses riesengroße Programm. Und last but not least natürlich erhalten Sie auch als Teilnehmer natürlich die sämtlichen Slides, anschließend auch nochmal mit dem privaten Link. Da können Sie nochmal nachrecherchieren. Und eine ganze Menge Sessions, nicht alle, werden auch auf Video aufgezeichnet. Und die werden dann sukzessive über unsere Portale jaxcenter.com und jaxcenter.de auch veröffentlicht. Da können Sie natürlich auch jederzeit sehr gerne reingucken. Bevor es losgeht, möchte ich natürlich nicht versäumen, mich kurz vorzustellen. Ich stehe zwar seit 17 Jahren hier, nicht durchgehend, aber mein Name ist Sebastian Mein, ich bin bei SNS Media, erstens Chefredakteur des Java-Magazins, zweitens Chief Content Officer nennt sich das. Ich beschäftige mich mit sehr vielen Themen, mit sehr vielen Konferenzen, mit sehr vielen Publikationen, die wir veranstalten. Aber natürlich, ich muss ganz ehrlich sagen, so viele Veranstaltungen, die wir machen, die JAX und insbesondere diese W-JAX hier in München, ist, um ehrlich zu sein, meine kleine Lieblingskonferenz, obwohl sie gar nicht klein ist. So, das große Thema, das im Raum steht, und jetzt kommt wieder das, was der Daniel sagt, dass ich immer frage, wie geht die nächste Slide? Jetzt drücke ich nochmal drauf. Jetzt, riesengroßes Thema, 34 Milliarden US-Dollar steht im Raum. Sie haben es alle mitbekommen, vergangenen Montag war das die Tech-Nachricht des Jahres, nicht des Jahrzehnts vielleicht, aber für 34 Milliarden, muss man sich mal auf der Zunge zergehen lassen, US-Dollar hat IBM die Firma Red Hat übernommen, beziehungsweise die Absicht bekundet, sie zu übernehmen im Laufe der nächsten 12 Monate. Das ist schon eine ziemlich gewaltige Übernahme, eine ziemlich gewaltige Dimension. Und tatsächlich ist es auch sozusagen die zweitgrößte Übernahme generell in der Computerindustrie und die größte quasi Softwareübernahme jemals, die es gegeben hat. Jetzt bin ich in die falsche Richtung gegangen. Sehen Sie mal, ich muss noch üben. Das ist das nochmal mit vielen Nullen. Ich habe nachgezählt. Ja. Also wie gesagt, eine fantastische Zahl. Was hat das alles zu bedeuten? Tatsächlich ist es natürlich so, dass so große Übernahmen, so großer Unternehmen mit so einem großen und komplexen Technologie- und Produktportfolio ist natürlich auch ein bisschen komplex zu bewerten. Auch viele Analysten und Beobachter haben sich so ein bisschen schwer getan, sozusagen so die eine Big Message irgendwie herauszuarbeiten. Jedenfalls war es ein Paukenschlag. Und ich wollte noch ganz kurz eben auch nochmal drauf blicken, die Firma Red Hat, jetzt nicht, weil die auch hier Sponsor sind, sondern weil es wirklich das große Übernahmethema eben jetzt die letzte Woche war. Die schon länger dabei sind, wissen natürlich, ich meine, Red Hat war erstmal sozusagen die Linux-Company. Rund um die 2000er Jahre gab es mehrere Anwärter, der große Linux-Hype, ganz viel Investitionen. Das Internet fast in den Kinderschuhen, die erste New Economy-Blase blähte sich gerade auf, bevor sie dann plopp wieder platzte rund um 9/11. Linux, ein ganz großes Thema. Aber dann hat natürlich die Firma Red Hat was Schlaues gemacht. Sie hat dann den Middleware-Anbieter, Open-Source-Middleware-Anbieter JBoss übernommen. Das war im Jahr 2006 und dann gehörte eben JBoss Application Server, das ganze Ökosystem außen herum, später dann eben Wildfly, gehörte dann auch zur Portfolio von Firma Red Hat und sicherlich die weitere große Story von Red Hat ist eben auch OpenShift. Ja. Natürlich haben die noch viel weitere Marken und Produkte, darauf will ich gar nicht eingehen. OpenShift ist wieder sozusagen die Plattform, die sich sozusagen Cloud-Style-Provisionierung ermöglicht. Das ist die Kubernetes-Plattform, auch ein ganz großer und starker Bereich. Das heißt also, anhand von Firma Red Hat fand ich eigentlich nochmal ganz interessant, sich zu überlegen, okay, sozusagen, wie hat sich auch die Wertschöpfung sozusagen im Stack von Abstraktion zu Abstraktion immer weiter nach oben geschraubt. Ja. Wie gesagt, das Thema Java Enterprise spielt in diesem Umfeld eine große Rolle, aber verändert natürlich eben auch seine Rolle. Das müssen wir hier aus dieser meistens doch Java-Perspektive auf dieser Konferenz schon genauer beobachten. Auch interessant ist, was sich nach dieser 2006 erfolgten Übernahme von JBoss durch Red Hat dann ergeben hat, nämlich 2 Monate danach, ich habe nochmal nachgeguckt, 2 Monate nach der Übernahme hat Amazon EC2 gestartet. Und EC2 ist eigentlich sozusagen die Elastic Cloud. Das war eigentlich sozusagen der Grundstein für Amazon Web Services, für AWS, das wir heute kennen. Das war eigentlich der Grundstein dessen, was quasi heute sozusagen als Cloud-Plattform definiert wird. Das begann genau um diese Zeit, als JBoss diese große Investition in das Thema Java Enterprise tat. Dann folgte das Jahr später Force.com, das war die Tochter von Salesforce und von Google, die ersten sozusagen Plattform-as-a-Service-Angebote. Cloud Foundry folgte 2010. 2013 dann Docker. Ich erinnere mich noch, dass hier vorne der Matthias Löbken, der ist über die Jahre auch immer wieder toller Speaker gewesen. Diesmal ist er nicht dabei, vielleicht nächstes Mal wieder. Hier vorne hat nach irgendeiner Keynote kam Matthias und meinte, Baschte, ich muss dir was zeigen und ich muss dir was erzählen. Docker, hier kommt was ganz Großes. Ich glaube, das war die Version 0.3 oder irgendwie sowas. Ja. Tatsächlich kündigte sich das an und es hat sich natürlich auch bewahrheitet, dass es wirklich den Technologiemarkt, die Art und Weise, wie wir Infrastruktur denken und auch praktizieren, ganz nachhaltig geprägt hat. Kurz darauf dann Kubernetes und last but not least natürlich auch 2015 nochmal Amazon kam damit mit Lambda-Functions vorbei. Mittlerweile gibt es auch von Microsoft und von Google äquivalente Angebote und plötzlich war das Thema Serverless im Raum. Das heißt also ganz spannenderweise parallel quasi zu dieser Hochphase von Java Enterprise begann eigentlich das, oder viele Strömungen sozusagen setzten ein, die dann definiert haben, was Cloud bedeutet oder was Cloud bedeuten kann und wo wir eben auch heute stehen. Cloud Native. Das ist das große Buzzword, das ist immer ein bisschen schwierig zu beschreiben, was meinen wir damit. Ja, über Cloud-Themen reden wir eben auch schon seit 8 Jahren auf dieser und auf vielen anderen Konferenzen. Ja. Und es ist immer ein bisschen schwer zu fassen, was bedeutet das, und insbesondere in Deutschland die große Skepsis gegenüber der Public Cloud. Ja. Aber tatsächlich, denke ich schon, gibt es mittlerweile einige Bausteine sozusagen, die in Summe das ergeben, wo wir feststellen können, okay, das ist anders als das Architekturparadigma, das wir in Anschlag gebracht haben, im Zusammenhang mit Java Enterprise, im Zusammenhang mit dem klassischen Java Application Server, der ja so lange Zeit wirklich den Markt dominiert hat, als Formfaktor gewissermaßen. Cloud Native, wie gesagt, interessanter ist auch daran natürlich, dass die Idee von Cloud Native ganz massiv, so würde ich das heute bezeichnen, eben von der Technologie Kubernetes getragen wird. Und Kubernetes in der Weise sozusagen das Versprechen Javas, möglichst unabhängig von der zugrunde liegenden Infrastruktur zu sein. Wir wissen, zu 100% ist das Versprechen natürlich nie eingelöst worden, aber möglichst und einen vernünftigen Grad an Unabhängigkeit in Bezug auf die zugrunde liegende Infrastruktur zu erzielen. Da ist wirklich Kubernetes wirklich heutzutage der Schlüssel, wenn ich darüber rede, dass ich auf verschiedenen Public Clouds möglicherweise deployen will, wenn ich eine Mischung haben will aus On-Premise und Public Cloud, whatever, da ist Kubernetes möglicherweise das Kubernetes-Ökosystem, möchte ich eigentlich sagen, der Dreh- und Angelpunkt, natürlich auch mit einer ganzen Menge weiterer Systeme, da bleibt die Geschichte natürlich auch nicht stehen. Cloud Native, auch nochmal hier the Big Three, wie man so sagt, ja, das sind die großen Public Cloud-Anbieter und ich habe mich immer schon irgendwie früher gefragt, okay, jetzt nimmt dieser Cloud-Pfad irgendwie Zug auf, ja, und was ist mit Big Blue, ja, man hätte eigentlich erwarten können, IBM, das Unternehmen, was weltweit Rechenzentren schon seit Jahrzehnten stehen hat, ja, und quasi im Hosting von Applikationen eigentlich massive Erfahrung hat, kam eigentlich ehrlich gesagt in diesem Cloud-Game nicht gebührend vor. Ne? Und ich würde es mal so interpretieren, dass nicht auch durch die Übernahme von Red Hat da wird der Begriff Hybrid Cloud absolut in den Mittelpunkt gestellt, dass natürlich jetzt da IBM nochmal in die Richtung geht und sagt, okay, wir sind diejenigen, die sozusagen euch mehr von der Infrastruktur her ansprechen, die für euch den Übergang aus dem eigenen Rechenzentrum in Public Cloud Angebote möglichst einfach machen sollen. Noch ein interessantes Detail, was ich vielleicht noch anfügen möchte. Wir haben in der Redaktion auch dann der Live-Übertragung der offiziellen Pressekonferenz beigewohnt und auch da nochmal wurde betont von IBM-Unternehmensseite und von Red Hat-Unternehmensseite, dass natürlich an Red Hat nichts geändert werden soll, dass der Spirit von Red Hat auch erhalten bleiben soll. Und das ist natürlich wichtig für die gesamte Community, weil natürlich ganz viele Red Hat-Leute natürlich in wahnsinnig vielen Open-Source-Projekten auch kontinuierlich und ständig aktiv sind und sichtbar sind und für ganz viele Software-Bausteine, mit denen wir tagtäglich arbeiten, viele Beiträge leisten. Ein kurzes Wort zur Programmstruktur dieser Konferenz. Wer die JAX und die W-JAX häufiger schon besucht hat, hat vielleicht über die Jahre beobachten können und falls Sie es nicht beobachtet haben, möchte ich es Ihnen kurz erzählen. Das Programm wurde sozusagen größtenteils durch diese sogenannten Special Days aufgebaut. Das heißt, also wir haben für relativ, sage ich mal, fein granular definierte Themenbereiche haben wir immer so ein Special Day, eben ein Tag, ein Thema, ein Raum, haben wir immer gesagt intern, definiert und sozusagen aus diesen Potpourri an Special Days hat sich das Gesamtprogramm der Hauptkonferenz zusammengesetzt. Tatsächlich haben wir letzten Sommer gesagt, jetzt gehen wir mal mit dem Besen durch und versuchen mal alles wieder ein bisschen neu zu denken, das vielleicht in die Jahre gekommene Konzept zu überarbeiten und haben es eigentlich sehr, sehr viel vereinfacht, ja, und haben eigentlich uns größtenteils auf diese Tracks definiert. Wir haben gesagt, eigentlich das Programm größtenteils basiert eigentlich auf diesen Themenbereichen, die hier angeschrieben sind. Interessant auch hier dabei, ja, obwohl wir eigentlich sozusagen von unserer, ich sag mal, DNA her aus der Java-Welt stammen und in gewisser Hinsicht auf jeden Fall eine Java-Konferenz sind und ganz viele Themen natürlich auch haben, die Java-Technologie zum Gegenstand haben, kommt hier Java gar nicht so viel vor. Thema Microservices, DevOps, Docker, Kubernetes, die ganze Data-Ecke, Data-Access-Ecke und nicht zuletzt natürlich Web-Development, Angular, JavaScript spielen auch eine sehr große Rolle. Selbstverständlich werden die meisten Themen, die hier sind, quasi aus der Perspektive von Java-Applikationen erzählt. Ja, aber auch da stellen wir wieder fest, sozusagen im JVM-Bereich, Die Technologie ist da, die Technologie ist reif, die Technologie wird mittlerweile mit einer sehr erfreulichen, schnellen Innovationsschlagzahl auch erneuert. Ja? Und die großen Fragen sind, glaube ich, wirklich für Sie alle, für euch alle momentan das Thema Infrastruktur. Wohin deploy ich alles? Welche Auswirkungen haben sozusagen auch die Provisionierungsumgebungen für die Art und Weise, wie ich meine Applikation baue, für die Art und Weise, wie ich meine Applikation auch ausliefere. Damit wollen wir uns hier beschäftigen, die nächsten Tage über. Und wie ich schon sagte, wir sind zuversichtlich und sehr gespannt, ob Ihnen das Programm gefällt und freuen uns natürlich auch über Ihr Feedback. Das sind, wie gesagt, die Special Days, die quasi noch übrig geblieben sind. Ja. Natürlich die Klassiker, will ich nur kurz darauf zu sprechen kommen, Java Enterprise und Spring. Das sind beides eigentlich auch die Tage, die immer so ein bisschen auch die Aufgabe haben, sozusagen so ein bisschen den Stand des jeweils des Spring-Ökosystems oder der Java Enterprise-Welt ein Stück weit zu reflektieren. Zum Thema Angular, weil es auch in der Java-Welt so ungeheuer wichtig ist, haben wir auch einen ganzen Day gebaut. Workflow Automation, Performance sind Sachen, die am Donnerstag noch stattfinden. Und zu den Business Technology Days möchte ich Sie auch sehr herzlich einladen. Da beschäftigen wir uns wirklich eigentlich mit Themen quasi aus einer technologischen Sicht heraus erzählt. Da beschäftigen wir uns aber mit Themen sozusagen der digitalen Transformation, wie man es heute sagt. Wir waren vor vielen Jahren noch am Suchen. Wir spürten, okay, etwas ändert sich in der IT-Industrie, etwas ändert sich generell in der Industrie. Sie kennen das Wort von Mark Andreessen, Software is eating the world. Und das ist eigentlich der Track, wo wir eigentlich viele Themen versammeln, die sich immer wieder damit der Frage beschäftigen, was passiert eigentlich, wenn Software sozusagen das Herzstück wird eines jeden Geschäftsmodells. Also auch das wiederum, das läuft hier parallel in der Konferenz und empfehle ich Ihnen sehr, auch ab und zu reinzugucken. Das war's von meiner Seite. Jetzt ist es mir eine ganz besondere Ehre und eine besondere Freude, unseren ersten Keynote-Sprecher anzukündigen. For this, I want to switch to English. Sorry, Russ, for speaking so much German. Russ Miles, well, he's a veteran in the Java world. He's a veteran as a software architect. He's speaking on so many conferences. He's a writer. And last but not least, he's also a musician. And he's speaking about trust and confidence through chaos, because we are entering now in a world where we have to deal with so much complexity, with so complex systems, that at least just bringing stuff into trouble maybe helps us to understand what's going on. Please give a hand to Russ Miles.
Good morning. Can you hear me at the back? Right at the back. Fabulous. Hi, so thank you very much for inviting me, to the organizers here for inviting me today. I've got a new song today to play, because I normally play the same one, and everyone gets a bit bored with it. So today we're going to be a bit different, and I'm just going to check I've got the sound right first. No, that's all right. Okay, just play the song first, just sets the stage, all right? Just sets the stage for the rest of the talk. Okay, you don't have to switch off, but if you do, don't worry, it's just the song first. Thank you for indulging me. Okay, so that sets the stage for just how bad things can get. And now I'm going to explain a little bit more about how much worse they can get. I'm sorry, I know it's like second day and you've all just woken up and you're really excited. You've learned loads yesterday, hopefully, and you're learning loads today. But I'm here to remind you that whatever you learn has to be seen through a lens. It has to be seen through a filter of disappointment. With that in mind, let's move on to the meat of the day. Okay, so first of all, who am I? I'm a member of this company now. We help people like you build reliable systems. And I'm a bit careful with that phrase, because I could say we do chaos engineering, which sounds really cool, but I'm going to explain in a minute why I love and loathe the term. We help people build reliable systems because that's genuinely what they want, as opposed to necessarily breaking them. So this is me, in a few years' time. Do you want to know who that is? Sorry, you want to shout? Bertrand Russell, yes. We share a name. That's about it. Now, he's a philosopher, and I consider myself a software philosopher. No one else considers me it, but that's what I characterize myself as, and it works for me. It means I think a lot about what we do and why we do it. And this year, I was very fortunate. I spent at least a month riding a motorcycle around the United States doing this, well, very similar to this talk, everywhere I went, including in the middle of a desert. It was amazing. I had everything from 180 people in San Jose to 5 in Vegas. Let me tell you, 3 of those were there for the free pizza. And this was me a month later. I rode a motorcycle to Mount Everest. Now, I think that's the best analogy for software development I've ever seen. Anyone that tells you they got a roadmap, show them that picture. It's a lot steeper than it looks there. It looks very flat. It looks like we're just doing it for fun. And this is what I got when I got there. This is one of my photos of Mount Everest. Beautiful, wonderful experience. I'll share it with all of you over a pint later on. The thing to point out here is that's what we think production looks like. Gorgeous, serene, a rock. But in the background of that very same scene was this: the world's worst toilet. You don't want those stories. So my point here is there's always a toilet in the background somewhere. And that's why I'm a part of the Chaos Collective. So we deal with people who are dealing with the fact that production is a challenging system to look after. And it's a sociotechnical system. There's a lot about technology on a conference like this, but when it comes to doing this, there's a huge amount of the social element, the people side of it, which is exciting as well, because people are the biggest cause of system failure ever. But we have to be careful with the word cause. Okay, so a quick parable for you of the ignored architect. I'll make this quick. Does anyone know what is the single biggest problem with being a software architect? It's being ignored. You've got loads of great advice, haven't you? You're full of it. Experience, hard-earned experience, scars. You could share it all with people. And what do? Yeah. So the technique you're going to learn today is going to be one where you learn how to make people listen. You learn how to remind people that non-functional characteristics of a system are why they function. I hate the term non-functional. It completely labels things the wrong way. Okay, so reliability. I want to share this. Reliability is the goal. It's what your customers want. Your users want this. They want to rely on your system. That doesn't sound like it's anything particularly big. It doesn't feel like an epiphany, really. The difficulty is making it happen. And we have site reliability engineering as a wonderful characterization of how you could approach the problem. And if you haven't looked into it, please do, and particularly if you look at error budgets, because they're massive to this technique. But ultimately, reliability is the goal, and resilience is what you can work on. You can build a system with the people involved as well, to learn and be more resilient in the face of the fact that it will fail. The fact that it will be that toilet. I'm not saying you're deliberately building toilets. I'm saying we just do. I'm saying reality is a toilet. There's a tweet I don't want to see later. And in the face of constant failure and the potential horrors of that bathroom, what are we going to do to make it better for ourselves? What are we going to do to provide reliability to our users? Okay, so John Allsborough, who I tend to quote almost every single time I do a talk now, characterizes it this way, that you can make a technical system more robust. You've probably heard of circuit breakers. You've probably heard of bulkheads. You've probably heard of defensive programming. All good stuff. But that's just technical robustness. That's being, I would argue, that's due diligence. Resilience is about learning how much better you can make your system. It's actually about learning loops. And for the time being, learning involves us. I know we have a lot of machine learning going on, but I don't think it's quite up to the job right now. So for now, it's about us. So we are the reason that we can get a resilient system. You can't have a resilient system that is just technical. It has to include the people, the practices, and the processes involved. So yeah, resilience is an investment in the time and attention of staff to carry out this strange thing called chaos experiments. Let's figure out what that is. So where did chaos come from? There's an official history, as all there is in these things, and the official history ignores all of the predated work, because that's what official histories do. So this is the official history. Netflix built Chaos Monkey, chaos ensued, everyone was happy. Apart from the people that phone me up and say, I've run Chaos Monkey in production, by the way. I get that regularly. Roughly every few months, I get someone phoning up going, we've run Chaos Monkey in production. I'm like, wow, okay. They say, it killed everything. Yep, pretty much what it does. We knew it would. Whoa, 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 stop there, Sparky. Why did you do it then? If you know, it's the first rule of chaos engineering. If you already know the outcome of the experiment, don't do it. You don't break anything in your system knowing it's going to make the whole thing collapse. You're not learning anything there. You might be learning a bit about yourself. You might be learning that you're a sociopath. But otherwise, you're not learning anything. Okay, but back to the official history. I tend to ignore it because I think there's better history than this. Does anyone know who this is? You want to shout out if you know who this lady is? Admittedly, it's not the famous photo of her. I'll give you that. But this is Margaret Hamilton, who's one of the lead techs on the Apollo program, if you haven't bumped into this story. If you haven't read the SRE book, it's right there in the beginning. So you're going to grab that because it's great. The thing about Margaret is she's not the point of this story. Don't get me wrong, amazing woman. But she's not the point of this story. The point of this story is that she knew the world's first chaos engineer. It was her daughter, Lauren. Her daughter, Lauren, used to go to work with Margaret. We used to go and work together at NASA. How cool is that? Can you imagine the bosses? What, you're bringing a child into work? This is serious stuff. Yeah, cool. She's coming in. Used to bring her daughter into work, and she would do whatever you do with a daughter at work. My work happens to be in my front room, and my daughter's there, and I know what I do, which is, how do I keep her busy? So daddy can do some work. So with my daughter, with Lauren there, what she did is she gave her a toy to play with. The mission simulator. To say I am jealous of this would be an understatement. Fantastic, given this amazing thing to toy with, play with. And she found something out. She found out you could crash it. That's what kids do. That's what I do. I don't think I've grown up at all. Basically, she found a certain key combo, a certain maneuver on the mission that basically flushed the navigational information out of it. Problem. So the reaction of NASA was perfect. You've probably heard this yourselves. The boss turns around and goes, don't worry. Our people are made of the right stuff. They don't make mistakes. We train our astronauts, software developers, project managers, operations. We change our people, we train our people to always be right. So the very next mission, this photo happened. This would not exist without Margaret and Lauren. Margaret learned from Lauren's ability to break the system and came up with some strategies, because the very next mission, those astronauts who were all made of the right stuff managed to flush all of the information out the system not long after takeoff. The moral of the story here is Murphy's Law is real. If it can happen, oh boy, will it. And it'll happen when you want to be out on a date, or when you want to be having dinner, or you would like to sleep. These are when Murphy's Law happens. If anyone says it can't happen, it will. I love watching the papers when you get an announcement from somebody going, this can't possibly happen. Anytime now. Okay. So what's the problem? Can't we work ourselves out of this? Do we really have a problem here at all? The problem is, a phrase I would like you to adopt, is that production hates you. And it doesn't just hate one. It's not, general. It hates you. It knows when you're doing anything else at all, and it wants to ruin your life. It's like a really horrible Santa Claus. It's watching you, seeing if you do anything. As soon as you claim that won't happen, it knows it's coming for you. And we've got more expectations now than we've ever had before. The reliability of our systems is huge. But not just the reliability, our feature velocity has gone right up. Everyone is now agile, aren't they? We're all fast. We're all delivering quicker than we've ever done before, which is great, by the way. I have a whole nother talk on why that's important to reliability. It feels at first like it should be feature velocity versus reliability, and it's not. It's feature velocity can lead you to reliability. It's really weird like that. That's for a different talk. And this is the nature of the problem. Now I'm going to abuse a system here called Cynefin. I am abusing it. I'm just using it as a framework. Anyone who's expert in this, take me aside afterwards, please teach me. But the point is, I know I'm abusing it. Okay, number one, you certainly aren't down in simple. Anyone here who's building a system that isn't Hello World is not delivering simple software and simple systems. Sorry, you're not there. It'd be lovely to be there because it's all about best practices. Someone can come along and say, just do X, and you do it, and you're better. That's great. What a dream that is. Every consultant in the room would like to be able to do that. But we all know we can't. At least we should know we can't. Instead, we are at least appreciate that we're in complicated, where there are good practices. I can come up to you and go, do this. You might be better. We're going to try it out. But I have some bad news for you. If you're doing distributed systems that have external dependencies, and let's face it, who isn't these days? Then you are no longer in complected. You're over in complex. Emergent is better here. We have to find what's better for you. It's a harder job. It's why a lot of consultants, when they encounter your software development system, do use that horrible phrase, it depends. Let's try it. And I've got even more bad news, because if you're building complex systems that move really quickly, change really quickly, which was the point of doing them, by the way, anyone here doing microservices that can't change their system frequently, why are you doing it? That was the whole point. It's an architectural style that supports, at scale, continuous delivery. That's all it was. Anyway, so moving on. If you've done that, you have a different problem. You are now in chaotic. Chaotic is not a nice place to be, because here we're surprised when there's something better. So wouldn't it be great if we had a technique that engineered us out of chaos? Welcome to chaos engineering. It's got nothing to do with making chaos happen. Okay, so there are lots of sources of these sorts of problems in your system. You're probably familiar with infrastructure. Everyone's familiar with infrastructure. But infrastructure gets a really bad rap. It's always the networks, isn't it? Those virtual machines that keep dying on you. Docker. It's not, actually. In my experience, those things are pretty reliable, ironically. But that's where we focus first because it's technical and we can destroy those really easily. More interestingly, there's lots more sources and potential multi-sources across the rest of the system. So we have platform failures. Anyone running Kubernetes? Anyone destroyed the control plane of Kubernetes for fun and kicks? If you do, you won't ever do it again. Applications. We write code that's wonderful at taking our world to pieces. And finally, the biggest cause, the biggest source, the wonder that is us. We create more failure than anyone else. Now, I should be careful here. You never stop understanding these things in terms of just the person. So if you just blame somebody, you lose. But when you look into it, one of the big factors involved is the fact we're human, and we will make mistakes. Tomorrow, I've got another session on chaos engineering. I'm going to share a lot of those real-world mistakes with you. Okay, so wouldn't it be great if we had a proactive, practical approach for diminishing system weaknesses, important point, before our users experience them? We've got postmortems. That's what we do after a catastrophe. You know, there's a big fire in production, and we sit down afterwards and go, my God, that was a nightmare, wasn't it? What are we going to do about it? Don't know. Blame Joe? Yeah, probably. There are postmortems, and I can go on for hours about postmortems, but these aren't about postmortems. These are about pre-mortems. This is doing small amounts of exploratory disaster recovery to your system before your users ever experience it. If you can imagine it can happen, it will. So probably try it and see how your system deals. Yes, you could do it in production if you want to learn really quickly. But you could also do it in staging if you're willing and able to learn there. The point here is this word I keep using over and over again, you're learning. Chaos engineering is about learning. So, to do chaos engineering, I'm going to give you a whistle-stop tour now of everything you need to know to do chaos engineering. At the end of this, I shall be distributing Chaos Engineering Alliance certificates. You are now all chaos engineering masters. No. Anyone who wants to start an alliance around chaos engineering, I will find you. And we will not have a nice conversation. Because I don't think we need it. It's really simple. So first of all, the mindset. First of all, we're going to never let an outage go to waste. We're going to take every single possible way of failing the system. We're going to learn from it. There is nothing as visceral as learning from an outage. And we are switching it around. We're doing pre-mortems. I'd also like you to think differently. I'd like you to think like a motorcyclist. Who here rides a motorcycle? Cool. Who here drives a car? Cool. Right. Car drivers. When you're taught to drive, you're taught that everyone else on the road can't see you. So you should drive defensively, right? I'm assuming everyone who drives a car, by the way, has a license. So you've been taught probably something along those lines. Motorcyclists, we're not taught that. We're taught that everyone can see us and wants us dead. That's how we live longer. Everything from the other car drivers, particularly the car drivers, to the little old lady with her dog, even the dog wants you dead. That way, boy, do you ride differently. And that's how I want you to think about production. It's not a passive system. It wants you dead. Okay, what's the process look like? Now, this is what we tell people we do. Like all good scientists, this is what we do. Okay, so first of all, I know quite a few scientists, and I know they don't start with a hypothesis. They start by poking the system, whatever it is, poke it, and being surprised. You know, they look at a theory, or they look at a model, or they look at an actual Petri dish, and they go, huh, that wasn't supposed to happen. we might have to do some science here, people. Then they come up with a hypothesis when they've been surprised by something. So you'll do the same with your systems. You'll look at them and you'll go, I'm sure it'd be fine if we just take out that network connection. Ooh, that wasn't fine. And then you think, okay, that's the start of a problem here, because that could go down. Let's do some science, people. If you're not doing chaos engineering as a scientific exercise to learn from how your system behaves, then you're just attacking your system. And that's probably not what you're trying to do. Okay, so I have to warn you of that. If you're in any way have a tendency towards being sociopathic or psychopathic, and if you don't know if you are, and you don't know anyone else near you that is, then you are. You probably don't want to do this technique. All right? You really don't want to do it. It's too much power in this technique for you. You'll enjoy it too much. So we start with a hypothesis. We say, I think the system will survive if this happens. And when I say survive, I mean it will stay within tolerance. Then I talk to everyone about this. Literally, I say, go to the team and go, we should think about this. You know, if this happens, and we agree it could happen, should we explore it? Then you explore it through an experiment. And tomorrow I'll be looking at actual concrete experiments and sharing them with everyone in the room as well. Look at the results. Start small. Increase the scope. You don't start big. Your first experiment should not be Chaos Monkey in production. That's not an experiment. That's a disaster. So you start really tiny. You go, yeah, what if this? Ooh, that wasn't quite what we expected. And you learn from that. And gradually you grow the scope of these things. And eventually, you might take them into production. Eventually, when you really want trust and confidence there. Finally, everything you've heard so far can be manual. We have a thing called the game day, which is one ritual for doing this. But you can also just do this yourself, manually, and you will learn. You could do it tomorrow. Actually, you're at the conference tomorrow. You could do it Thursday. But you should do it. Okay, finally, if you find that you want to do these experiments more and more frequently, and you will, because you build trust and confidence now, but if you don't run these experiments frequently, you don't know tomorrow if that trust and confidence is still valid. So we run these things in an automated fashion, just like anybody else in our industry, because we don't want to have people doing them all the time, but we do want to do it all of the time. Chaos engineering is another one of those continuous techniques. Continuous integration, continuous delivery, continuous chaos. Okay, some ethics for you. This is a big one. This is the single reason that if you don't get this right, chaos engineering will fail in your organization. You have to have skin in the game. What that means is if you're going to help teams explore weaknesses in their systems, you have to be part of the pain. You have to experience with them their learning. You have to take them through the whole learning loop. If you don't, then you will fail because you'll turn into one of those conflict relationships. You'll be like QA that we used to have or tests that we used to have, with the development team trying to game you and get past the chaos with minimal pain. You don't want that. It's about all of us learning. In fact, when these things get mature, the chaos engineers don't run the chaos ever. The teams run the chaos. They choose when, they choose what they're exploring, they choose what weaknesses. You as a chaos engineer are a supporting group to the team doing it. 2 key practices. Game days, they are the most fabulous fun in the world. I've got to talk about this briefly because tomorrow we look at automated chaos engineering a little bit more. Game days. Has anyone, who here's played Dungeons & Dragons? Excellent. Those who haven't, you haven't lived. Game days is Dungeons & Dragons when you get paid to do it at work. You get to get everyone together and go, what happens if something's broken in the system? How do we deal? Sometimes you break something and you see how we explore it. Sometimes you tell everyone what you've broken. But every time you're setting up a scene and you're seeing how everyone performs. Tomorrow I'll be telling a lot of stories about how that can go wonderfully well and wonderfully bad. But it's the most powerful technique, and you can do it Thursday or Friday, whenever you get back to work. You could do it just for fun amongst your friends. And normally you do this sort of thing in staging first. I mean, don't get me wrong, you want a bit of stress, but not that much. So learn first in staging if you possibly can. Then we automate for chaos experiments. Chaos experiments are where we take everything we do in a game day and we make sure we can automate it so we can continually gain that trust and confidence. Okay, so how do technical folks tend to react to chaos engineering? They say don't do it. I've had this conversation many times. It's getting better because people are understanding what chaos engineering is and what it isn't. But when you first say to someone, we're going to do some chaos engineering, do not be surprised if they turn around and say, please don't. Why would we want that? Particularly if they're a bank or a health system, both of which I've worked on. So I tend to drop the term in those circumstances. I don't get too hung up on it. I use a different term, and I'm going to share it with you right now. I use continuous, limited scope, disaster recovery. That gets you a budget. I talk about production incidents. I don't sit there and go, do you know what we're going to do today? We're going to destroy some stuff. Everyone cool? No, I say, we're going to learn something. Has something happened in the past that hurt us? Maybe we could explore a small-scale version of that and see how we deal. Okay, so some quick rules before I finish on Chaos Club. Number one rule, don't talk about Chaos Club. What I mean by this is you don't have to use the term. You are trying to find weaknesses in your system and try to learn from them. The term is cool. You can call yourself a chaos engineer later. Start doing the practice now. It's about learning, not about hurting things. Chaos engineering is a deliberate practice. We are deliberately learning and improving our systems, the whole sociotechnical system, based on discovering, surfacing system weaknesses and overcoming them. That's the pitch. Chaos should not be a surprise. I would really like no one here to go back and go, do you know what I'm going to do? Bonk, network gone. And see who notices first. Once again, you're probably in sociopath area now. It should never be a surprise. Everyone knows chaos is going to happen. They might not know what's going to happen, but they should know it's going to happen. In fact, by definition, because chaos engineering is about discovering and surfacing weaknesses, you probably don't know completely what's going to happen, which is a little bit of a confessional, really, because many people would like to do chaos engineering in a perfectly safe way. You could do it in staging, and it could be safer than anywhere else, but there is no such thing, when you think about it, as a perfectly safe chaos experiment. If it was perfectly safe, we wouldn't learn anything from it. Because we're interested to know what surprises us when we do an experiment for the first time. And I mentioned this before. If you already know how it's going to go, don't do it. That's not really the point. I have had people argue this with me. They said, well, I'd still like to do it because I'd like to see what else goes wrong. Well, fix the first thing first. Then worry about the other things. You know, it's actually quite hard to learn multiple lessons at once. You usually focus on the thing that's hurt you the most. So I would prefer you to try and fix the one thing. You should run an experiment, one thing in mind. I think the system will survive. If you don't think that, keep improving the system until you run the experiment, before you run the experiment. Okay, so one of the things that we do with organizations, the next sort of thing we do, is we then get them involved in developing their own chaos platform. This is something that everyone can use in an organization to do chaos. Remember I mentioned earlier, everyone does chaos. It's not just a special group that sit there in a dark corner, occasionally doing chaos. That's not what we do. And what we do with a chaos platform, first thing you need to do, give everyone, when you're developing your own chaos platform, is you need to give them control over it. No one wants to sit there and go, I wonder what chaos is running today. And not be able to see it, not be able to observe it, not be able to control it. Observability is a massive thing. Observability can be summarized as, can you debug your stuff in production without changing it? I like that definition. It comes from Charity Majors. Chaos is part of that. Chaos should be debuggable too. Chaos also needs to be a solid part of your picture of the system when you're running it. So when you look at your system, you should also be able to see what chaos was running. Because otherwise, you might think your system is collapsing, and actually it's the chaos running doing it. part of not being a surprise. It's extremely collaborative. You will work with others on chaos all the time. If you find yourself as a lone chaos engineer, you're probably either you're in the very early stages of doing anything with it, or you kind of need to come out of that and work with others. It's most powerful as a collective learning experience. And you'll need to customize it for your world. Everyone's systems are different. You'll need to make it different for you. Okay, so in summary, I have a confession. Earlier on, I made the broad statement that when you're working with distributed systems that evolve quickly, there are no best practices because they're not simple. Here's my confession. For most of my career, I've helped people with microservices, I've helped them with event-driven systems, I've helped them with different cloud-native approaches. All of it comes with a big warning label that says, be aware of your context. Chaos engineering doesn't have that label. Anyone can benefit from exploring the weaknesses in their systems and overcoming them in a rigorous, scientific, simple approach. So chaos engineering, my take, is one of our few best practices. It's up there with TDD. You know, just do it. Okay. Where to go next? You can look at the platforms we've got. Let me just jump to the last slide now. Boom, boom, boom. Oh yeah, let's do that one quickly. Books are coming. I'm writing a book right now for O'Reilly. There's already the free Chaos Engineering book. If you haven't got it, why not? Who's downloaded the free Chaos Engineering book? Did you not hear the free part? It's free. Unfortunately, I don't think it's in German, and I apologize for that. But there is a free book from O'Reilly. You can download it right now. You can break the whole internet here and just grab it. It's a fabulous book. It's a little bit Netflix-centered, but it's a fabulous book, and it'll get you started. And then by tomorrow, when you come to my section, we can deep dive into doing it yourselves. So grab the book, then watch the sessions today. Then this evening, homework, read the book. It's a short book, 60 pages or so, nothing. It's like sit in the bath, read it kind of time. Okay, there's that book. But then I'm writing another book, which is for practitioners, how to do chaos engineering for real, in real companies. And that book will hopefully be coming out sort of Q2 next year. So books are coming. And then finally, and also courses are coming. I'm launching a course later on today, and I'm calling it Building Reliable Systems. And its subtitle is How to Be Wrong. How to be successful at being wrong. Because systems will break. So that's how we're going to deal with them. So yeah, mention that too. And finally, I'll see you out on the road, hopefully. Come and talk to me. I'll be around the conference all day today, all day tomorrow. Come and have a chat with me about any of what I've talked about now, even including the microservices and cloud-native stuff if you wish. Have a fabulous conference. Thank you for listening to my music. And have a great one.
Thank you so much, Russ, for the music and, by the way, also for the presentation.
One second. Before anyone goes and leaves or stands or anything else, hang on. No, you're coming in.
Okay.
You might actually need to hold it because you're a slightly taller person.
Okay.
Like fundamentally slightly
This direction.
taller.
Hey. Turn around. Hey.
Smile, everybody. Hang on. Everybody, smile.
Apologize.
There we go.
Cool.
If you can't do that on stage, what can you do?
Thank you very much. And as Russ already said, you're doing a session
Late tomorrow.
at 6 o'clock.
Ja.
In the evening, not in the morning.
Yes.
Cool. Okay, bevor es losgeht, ganz kurz noch 2, 3 Housekeeping-Sachen. Erstens, wie gesagt, Holen Sie sich die App für Android und für iOS. Ja. Erstens gibt sie Ihnen das Programm. Sie können sich da Favorites machen, können sich leichter durchs Programm durchnavigieren. Zweitens natürlich, ganz wichtig für alle unsere Speaker und für uns selbst als Veranstalter, geben Sie Feedback durch die App, bewerten Sie die Sessions, was Ihnen gefallen hat, was vielleicht beim nächsten Mal besser werden könnte. Wir gucken uns das ziemlich genau an, geben die Feedbacks selbstverständlich auch weiter an die verschiedenen Speakers. Das ist sehr, sehr hilfreich. Und last but not least nochmal, ich habe vorhin schon gesagt, wir sind hier wirklich sehr, sehr viele Leute. Und es ist sehr wichtig bei den Pausen und Catering, tolle Sachen zu essen, tolle Sachen zu trinken, gibt es auf 3 Ebenen. Einmal hier die Treppen rauf, einmal hier auf der Ebene und einmal eine Ebene tiefer. Wenn es irgendwann sehr voll sein wird, wechseln Sie einfach wie so ein Load Balancer auf die andere Ebene. Das war's von meiner Seite auch. Ja. Jetzt wünsche ich Ihnen eine fantastische Konferenz. Verteilen Sie auf die vielen, vielen Sessions. Wir treffen uns heute Nachmittag wieder zur Keynote hier. Machen Sie es gut, bis dann.